The robot has a large base, which provides plenty of room for the cage for one group of cans, the bin for the other group of cans, and the gearbox, which has the claw system attached to it. There's a small seat attached to the left side of the robot, which is where the battery is held. Two sets of plates are attached to the left side as well, providing a spot for the Arduino Mega 2560/LCD combo, which is thin, without getting in the way of the other component. Two large wheels are attached to the back, one on each side of the base, and a single wheel is attached towards the front of the robot. The front of the robot has a rig attached to it to allow the robot's tracking sensors to sit low enough to the ground. Another rig is attached to the rig for the sensors, which allows the ultrasonic sensor to be attached in a position where it can get an accurate distance reading without interfering with the operation of the rest of the robot. The robot has 3 gearing systems. 2 of them are on the back of the robot, and the third is in the gearbox system. The 2 on the back of the robot transfer power from their respective motors to the wheels that they're attached. The one on the gearbox system transfers power from the motor it's attached to the robot's claw. The robot has 1 ultrasonic sensor, 2 potentiometers, and 4 light sensors. 3 of the light sensors are used to ensure that the robot follows the track correctly. The ultrasonic sensor is used to detect how close the robot is to a can, and then stop it at the right distance. 1 potentiometer is used to detect the claw position. The ultrasonic sensor is used to detect how close the robot is to a can, and then stop it at the right distance. 1 potentiometer is used to detect the position that the claw system is in, and then lower or raise it as needed. The other potentiometer is used to ensure that the claw grabs or lets go of the current can when appropriate. The 4th light sensor is used to detect the color of the can that the robot is currently grabbing and ensure that it's dropped in the cage or the bin, depending on that can's color. The robot has 3 motors and 2 servos. 2 of the motors are attached to the back of the robot and are used to cause the robot to move and turn along the track. The 3rd motor is attached to the gearbox system and is used to make sure that the claw system is moving in the right direction, depending on whether or not it is currently lifting up a can. The 2 servos are attached to the left and right claw and are used to move said claws into position depending on whether the robot needs to pick up a can or let go of a can. There are no special mechanical mechanisms. I encountered several major problems over the course of the project, most of which prevented me from getting the robot to function properly. I'll get into those problems later on. The first problem that I could actually solve was spacing out the various components of the robot so that there was room for it to function correctly. The solution to this problem was adding the side compartment for the battery, the side place for the Arduino/LCD, positioning the gearbox system as close to the front of the robot as it could be placed, and attaching the claw system to the very edge of the gearbox system. Another major problem that I could solve was making sure that the ultrasonic sensor would consistently detect a can's position if that can was in the sensor's range. The solution to this problem was putting in a delay of a millisecond between pings. The third major problem that I could solve was making sure that each part of the robot's code would only be active when all of the parts of the robot were in their proper position. The solution to this was using while statements, several of which had conditions that involved an AND state. The code has 2 major parts: moving the robot and having it grab the cans and dropping them into their proper bin. The robot's movement was done using light sensors to determine when the robot needed to turn. The claw's movement into their open position was put into its own sub-function, which was then put back into the grab function. The code was ultimately streamlined by creating separate functions for each item the robot needed to do. Several of the separate functions involved a bunch of if and while statements. There were 3 major problems that prevented me from getting the robot to function properly. The first and biggest of these was that there were points where the robot would just go off the track created by the white tape altogether, no matter what combination of if or while statements were used for that segment, or how close or far apart the light sensors were. The worst part about this problem is that the robot would actually follow the track if that portion of the code was uploaded as its own program. But as soon as the code controlling the ultrasonic sensor was put in, then the portion of the code controlling the light sensors would suddenly stop working. The second was that the gearbox would sometimes continue to lower the claw, even after the potentiometer for it read that the claw was low enough, even if the chosen point for it to stop was relatively close to the claw facing directly upward. The final problem was that the light sensor for the claws would not properly detect the color of the can unless the can was right up against said sensor, no matter how big or small the thresholds for the two can colors were.